Alright guys, so this is a video of limits, page 26, just a mixed review of the problems. Remember, we always want to plug in first if we can. So plug in first. If I get 0 over 0, I may need to go to some of my rules that I have. So your number one, guys, you have the limit as x approaches 0 of 2 sine of x, plus 3 cosine of x. Okay, so we're going to plug in 0 for these. So 2 sine of 0 plus 3 times sine of 0, or 3 times cosine of 0, All right, if you go to your unit circle, you know that the cosine at 0 is 1, and we know that the sine at 0 is 0. So you have 2 times 0 plus 3 times 1, which is 3. So this limit as x approaches 0 is equal to 3. For number 1. Okay, let's look at number 2. So we have the limit as x approaches 0 of x squared plus 1 all over 2 minus cosine of x. All right, so again, let's plug 0 in. So 0 squared plus 1 over 2 minus the cosine of 0. All right, unit circle tells me the cosine, the x value at 0 is 1. So we have 1 over 2 minus 1, which is 1. So this limit is 1 as x approaches 0. Okay, number 3. We have the limit as x approaches 0 of x over tangent x. Okay, and this is a special case. So these limits, this is actually what this graph looks like. All right, you have all your tangent looking graphs. Okay, and then right here, this graph comes up and down and it hits the y-axis. All right, which is when x is 0, it hits this right at this value of 1. So this limit, you just look at the coefficients, and in this case, it's 1 over 1, which is 1. Okay, number 4. Same type of problem. The limit as x approaches 0 of x over sine of 3x. Okay, again, we look at the coefficients. So it's 1 over 3. So this one is going to go to approach 1 over 3. Okay, so if you're looking at number 5, remember these tangent problems react the same way. So we're going to look at those coefficient. All right, you can't have 0 in the bottom, so you go to that coefficient rule. So this one's going to be 2 over 1 or just 2 for the limit as x approaches 0. Number 6, we need to split up. So this is x over x, okay, plus sine of x over x. So what we do is we look at the coefficients of these. So 1 over 1 and 1 over 1. So this ends up being 1 plus 1, which is 2. Okay, for cosine, it looks like this, it goes up, and then it goes down to infinity when x starts to approach 0. Then it comes back on this side, all right, and kind of does the same deal. All right, so here, one limit on the right-hand side is positive infinity, one limit is negative infinity. So we say that the limit for this does not exist because those limits from the right hand and the left hand side approach 2 different values. Okay, for number 8, again, just looking at the coefficients, this one is just 5 over 4. Okay, let's look at some of these other problems. So the last 4. Okay, so here is 9 through 12. On the first one, we have the limit as x approaches 0 of 3x cosecant of x. So what we have to do is we have to remember that the cosecant of x is the same thing as 1 over sine of x. Okay? So when we plug in 0 for this, all right, we get really 3x over the sine of x here. All right, so when you plug in 0, you get 0 over 0. So we've got to look at these coefficients. The coefficients are 3 over 1, so this limit is going to approach 3. Okay, and you can verify this in Desmos with a graph, and you're going to notice that it does go to 3. Okay, on the next one, so this cosine has a kind of has a weird shape. We briefly talked about this in class. All right, and this goes through the origin. So the limit as x approaches 0 for this graph is 0, and that's just a kind of a weird rule that we verified in class in our notes. Go back and look at the end of our notes section. You'll see this exact function. Okay, and we know that that always goes to 0. Number 11. So what I'm going to do on number 11 is I'm going to split it up into 2 pieces. So we have the sine of 3x over x, and we have plus the limit as x approaches 0 of tangent of 5x over x. So again, we know from earlier that it just goes to these coefficients. So sine of x goes to 3 over 1, or just 3, plus tangent is also the coefficients as well. So this is just a 5. So this limit is going to approach 8. And again, you can verify this in Desmos on your graphs. Okay, number 12. All right, tricky problem. First thing that I notice is that there is no x in the bottom of this fraction, so I can't look at the coefficients. All right, remember, always plug in. That's the golden rule of limits. All right, always plug into your function, see what happens when you put in 0 for x. So here we have the tangent of 2 times 0, so really the tangent of 0 over 3. So we have to think about what is the tangent at 0. So tangent is really sine over cosine. So the sine at 0 over the cosine at 0, all divided by 3. So what is the sine at 0? If we know the sine of 0, the sine of 0 is 0 over 1 is the cosine at 0. Okay, all divided by 3. Well, we know anything over 0 is just 0. So this whole limit has got to go to 0. Okay, so that is just a quick overview of the trig functions that we had in class from yesterday. I hope this video helps you guys. I hope that you'll watch it, help you study for your test that will be coming up. All right, thanks y'all. Happy calculus.